Hello everyone, this is Khaled from Retro Nerd. Today we're gonna work on a project that tackles a personal problem for me. A little bit of background, I live in Palestine, and in Palestine we don't get water regularly. We don't get water 24/7. Instead, there's a schedule where each kind of district or area gets like water for 2 or 3 days a week, and you don't get water for the rest of the days, which means that the most prominent feature of the landscape in Palestine is actually water tanks on top of roofs of buildings. You can see them everywhere. One of the issues also that happens is that depending on your altitude in the kind of area you're living, because like any other system of connected tanks, water when start filling up, it will fill up the lower areas, then kind of the higher elevation. And I happen to be living in an area where kind of a higher elevation. So basically what happens is that even out of the 3 days that we get water, it doesn't actually, my tanks doesn't get filled in the beginning, so I have to wait kind of towards the end of it. And it's always kind of a gamble that whether you'll get your full, the whole tanks filled up, because I have, of course, as a family, we have more than one tank. So basically, it's not always the case, and you have to kind of make sure that your tanks are filled within the time you have where the water is on, or otherwise you'll end up spending the rest of the week. You have to wait to the next kind of cycle to fill. And what that means is that whenever the water is on, I keep going up to the tanks on the roof and basically checking if the tanks are filled to the like full or not, and what's the level, if there's any problems, because sometimes because they cut the water back on and off, you get this kind of, I don't know what they call it, air inside the pipes. So when the water comes back again, it doesn't fill the tank. So anyways, so basically you have to check that everything is going and the tanks are filling up, and it's becoming something annoying for me, to be honest. So I decided to build a small kind of DIY project to solve this. Not to solve the problem of water, of course, that's much bigger than me, but the problem of going to the roof. So what I decided is that I want to build something that I will be able to tell the amount of the water in the tank from my phone. Okay, and I know there is systems that are expensive that can do this. Now there's like systems to measure the water level in like wells and big tanks, but I'm not talking about that. I'm talking about something that's probably less than $50 worth of like equipment, putting it together, and it's kind of something interesting that we're gonna build it now. So what's the plan? The plan is basically to build the whole system using an Arduino kind of chip alongside the sensor. Okay, so what are the parts that we're gonna need for this project? First of all, of course, we're gonna need the Arduino board. This one is based off the ESP8266. I think it's called Wemos D1R1. The nice thing about this board is it has a Wi-Fi chip in it. So basically, you don't have to buy another Wi-Fi chip to connect. If you don't have Wi-Fi where you're gonna put this sensor, you might wanna use a different model that has the GSM where you can put a SIM. So this is the first one, and I'm gonna put all the parts in the description, and I'll put on the screen the price of each part when I made this video. The next part we're gonna need is basically the ultrasonic sensor. It's the HCSR04. And again, I'll put all the details on the screen. Next, we're gonna need a screen. This is not absolutely necessary, but it's easier for us to kind of have it to show us the readings while we're developing it. Of course, the downside is that it will draw power more, so probably in the final product we'll not have the screen, but this is a 16:2 screen. It has the driver, there's a driver that's already connected to it. To make it easier, we only connect 4 cables, 2 for power and ground, and then serial communication with 2 cords. The next, we're gonna, of course, use some cables. These are the cables, basically jumper cables that connect all the parts together. We're gonna need 8 of those. After this, we're gonna use some kind of a container. This is like an electric kind of, hopefully waterproof container to house all the things inside of it. And we're gonna use some kind of wood pieces. We're gonna glue it inside something like this to kind of screw all the boards to it, to these like wood pieces. This is like part of I don't know, wood game, I don't know what it is. But we're gonna glue the wood inside the container like this and screw the pieces on the wood. Also, we're gonna need, for the final product, you're gonna need a battery, which is a 9-volt battery. This is like boxy thing. So this kind of battery, the 9-volt battery, because the board needs between 7 and 12 volts, and this battery gives 9. And this kind of cable, which basically connects the battery to our Arduino board. And more or less that's it. Of course, we're gonna use a glue gun, a hot glue gun, to stick the wood to the container. And by the way, the Arduino board comes with its kind of USB cable, data cable that you need to program the thing. And finally, and this is very important, we'll end up, after thinking about it, we're gonna need this sensor, because we'll start with the HC SR04, but the problem with that sensor is not waterproof. And once you have it inside the tank, you can imagine that won't work for long, especially with all the humidity. So we'll end up in the final product using this sensor, which is a waterproof version of the HC SR04. This one is called GSN SR04T, which is basically the same model. It works the same kind of concept. The only difference between both of them is basically this one, the SRT, is much more, I think it's much more accurate. The range starts from 3 centimeters up to, I don't know, like 4 meters or something. While this one starts from, I think 25 centimeters. So if we want to test on small tanks, we're going to use this, because when we're doing the testing, but when we finalize the project, we're going to use this one. And 25 centimeters is still okay, because the tank have, a gap of more like 30 centimeters in the top, between the top of the tank and where the water gets to. Okay, so on to the connections. Each of the sensor and the LCD both have a ground and a VCC pins, basically for the power. So we'll go ahead and connect the VCC to one of the 5 volts on the Arduino board, and the ground to any of the grounds. There is, I think, 2 grounds and 2 5 volts on the Arduino board. Then for the sensor, we have a trigger and echo. So basically what we'll do is the trigger will connect it to D5, and the echo will be connected to D6. And for the screen, the LCD, the SCL goes to the SCL port on the Arduino board, and the SDA to the SDA. So let's try it together. You'll notice that the screen will turn on, and one tip that I fell for when the beginning is that make sure you try to adjust the brightness of the screen. Basically, you can't see anything on the screen, it has to do with the brightness. Okay, so the next 2 connections that we need is basically, as I said, the SDA and SCL. We're connected to the screen. It's time now to kind of connect it to the PC and try to kind of code a little bit to show something on the screen. Okay guys, so going into the Arduino IDE, I'm not gonna go into how to install the IDE, how to connect things. Basically, there's many tutorials on that you can check out. But basically, I'm gonna talk quickly about how we're gonna basically use the LCD and print something on it. You're gonna need the Liquid Crystal I2C library. It's also, you can find how to install through the same IDE. The first thing we're gonna do is create our Liquid Crystal kind of object, which is basically with the hexadecimal address. Mine is 27. You can get this from the manufacturer. Most of them are 27, I think. 16 characters by 2 rows. The most important part at this stage for us is basically the setup function, which runs once when the whole chip starts. We're gonna initiate our LCD, we're gonna turn on the backlight, we're gonna print welcome to, and set the cursor to the second row and say the Retro Nerd, our channel. The loop function is not that important. We'll need it later on, but basically this is what the chip will be doing over and over and over when it's running. So let's go ahead first, try to kind of compile the code, make sure it's working. And after the compilation is done, if there is no error, you can go ahead and basically upload it, I guess. And voila, let's see. Oh, that's it. Welcome to the Retro Nerd, and please subscribe. So let's go ahead right now and move to the next step, which is basically connecting our ultrasonic sensor. Okay, so what's next? We need to program it. So the first thing we need is to define two pins, as we said, the echo pin and the trigger pin. As you remember, we connected it to D4 and D5. Then few variables for our calculation, the duration, which will be read from the sensor itself, the distance that we will calculate, few kind of constants, which are how the distance is it when the tank is empty and how much will it be when the tank is full. This is of course depending on the tank you have. For testing we start with 3 and 13, and this is basically a measurement of the smallest, like I have a small jar that we'll test on. Then we have basically the level, which will be the output basically. In the setup, the only thing we need to add is basically defining which pins is what type. So basically we tell the Arduino that the trigger pin, which is pin 5, the 4, is an output because we send the trigger on it. And we tell it also that the echo pin, which is a D5, is an input because we read from it. In the loop, we just need to add basically how to read and write to the sensor. So basically what we start with is that we send the low to the trigger pin, which is basically turning it off. We wait 2 milliseconds. Then we send a high voltage, which is basically 5 volts, to the trigger pin. We wait 10 milliseconds and then we turn it off again. So basically this is how we trigger the sensor to read. Then we read the duration from the echo pin using pulse in with a high. This is how you read basically the duration. Then we calculate the distance. This is the formula of the distance. It gives you the distance centimeters. Then we'll print it on the screen. Then we'll calculate the level. Of course, sometimes you'll get weird readings. So if it's less than 0, it's 0. We'll print it on the screen. Everything looks cool. Let's try to compile it first. Make sure it compiles. And then we'll try to send it to the Arduino board and see what happens. Okay, it compiled. Let's upload it to the chip. Okay, welcome to the Retro Nerd. Please subscribe. Okay. So we're getting distance as 0, which is not what we were expecting, right? Because this is the sensor. The whole idea is that when you put your hand there, we should see it's measuring the distance. So let me try to figure out why it's not working and come back to you guys.
2,000 years later.
Okay guys, so I got it working. I had to fiddle around a little bit. I don't know what exactly was the problem, but what I did is I moved the echo and trigger pins to D5 and D6. So now our echo pin is D6 and trigger pin is D5. And I ran it, it's working right now, but we'll compile it together and see, basically make sure that it all works. So let's see. So now, okay, nice. So it's now showing 171 centimeters, measuring to the roof. If I put my hand in front of it like this, hopefully it will read like 10 centimeters. If I pull it more, 4 centimeters. I think the minimum is 4 centimeters. So now it's working. The next step for us is actually to take the whole thing and use a small jar or a tank and see how it works. Okay guys, so to test it, of course, we need to kind of put the sensor on some kind of a mount so we can put it on top of the tank. So what I'm using, as you can see, I'm using plastic straws. So now it's on top of the tank, right? Everything seemed dandy. Let's push this a little bit inside so we make sure it's not spilling, doesn't flip over. Okay, let's power up. Let's make sure if it's okay. You need to make sure that's pointing down so you get a right measurement. Let's power up the whole thing. Nice. And see the reading. Okay, so it's 13 centimeters, which is the height of the container. That's absolutely right. And it doesn't have any water, so the level is at 0. Let's start pouring water inside the tank and see what happens. Okay, you'll get this. Now it's 14. Okay, now it's 12. It's at 10%. Nice, nice. 11 centimeter, 20%. Okay, let's go faster. 9 centimeters, 8. We're at 50. 6. I'm done with the whole thing. So basically we're at 90%. The bottle is done. I don't have any more water, but anyways, that shows the point. I think we can remember that this doesn't work in real life, because this one, if it stays, this sensor, if it stays in the tank for like a week, it will be corroded away and die. So we have to replace it with the other sensors. You know, we got the waterproof one, this one. So, and basically the problem is we can't test with this sensor here because the minimum range for this sensor is 25 centimeters. Okay guys, so one more thing before we go and fit everything together is we want to make sure first that the other sensor works with our setup. And let's power up the system and see. Basically it should give us a measurement. It's pointing to the wall, so let's see how much distance do we have to the wall. So okay, 218 centimeters. If we put our hand, it should, okay, so now it's 22 centimeters if we remove our hand. So now we know that's working. The other thing we want to do, look at how we're gonna get the signal to our iPhone or our phone. Basically we're gonna use a site called Circus of Things. Just go there, sign up, and inside the website, the site, you need two things. First of all, we're gonna define our signal, and the way to add a new signal is basically you go to your workshop, and inside the workshop you click add. There's the new signal. You can edit everything. Let's call it whatever you want. Water level. Come on. Water level, and you can add whatever you want there. So basically you need the key, and you need another thing is that from the profile, from the account, you have to get your token, which is basically this thing. You have to copy it. Okay, so the last thing, as I said, is basically adding the code for the Circus of Things. The nice thing, they have a lot of libraries on their website, so you can download it. I found a library that basically is built for this Arduino device, and it uses the Wi-Fi, and you can use it to just send data. So basically what we added is, this is the library. I've added the header file. You need a little bit of definition. So the SSID, the name of the wireless network it should connect to, the password of that network, the token, the one you got from your profile, the water level key, which is basically the key of the signal we created. The server, of course, is www.circusoftthings.com. And then you create the actual object, which is Circus Node MCU. You give it the server, the SSID, and the password. In the setup, we just need to add this object to begin. So basically what it does, it connects to the Wi-Fi and gets everything ready, and for sending data. And the other thing is just simply you call that object and tell it to write. You give it the key of the signal, the level, which is basically the measurement itself, and the token, and this should work. Let's compile this, and hopefully we'll see something. So basically remember, the level is at 0 right now. And let's do something here before it's just for testing. Let's put 15.5 or 15 as the value to send, because we don't want to send 0, we want to send something other other than 0, but remember to return it back to level, so it will actually submit the level when you actually send the signal. Let's compile it, hopefully it will work, and once we have it uploaded, we should see, after the screen flickers and everything, we should be able to go to the circuits thing and see that we have at least one reading. It will continuously send readings, but basically we'll see the first reading and confirm that actually we've sent the data to circuits of things. So now it restarted. Let's flip to the website, and here we see it. Already we got our first signal on the website. It's 15, and you can, inside the website, I think you can see all the samples. So now we know that the whole thing is working. Let's just go back to Arduino IDE and make sure that we set it back to level, so it reports the level. Of course, you can report whatever things you want. Okay, so next we're gonna tackle the housing box or thing that we bought. When I bought it, they said it's waterproof, but I really doubt it, because these things, I don't know if you can see, let me show you, these things just come off. So what I'm gonna do is I'm gonna use some sealant, like your standard average sealant. Okay, so I think this is all of them done. Now we need to kind of put these wooden sticks, the ones I told you about from the game. By the way, this is the game. It's a cheap knockoff of another game. It's called Blocks, but the kids don't play it anymore. Anyway, so I use it for my project. So the plan is we want to put 2 blocks here, okay, to mount the Arduino board on top of them. Let me take off the gloves so we don't put a lot of sealant. Okay, so this will house the Arduino, something like this, alongside with the battery. So the battery will go there. Of course, because of the size of the Arduino with the adapter, we have to do it something like this to figure out a way, snug it in. So this is the plan. Let's stick everything. Okay, so now we'll leave them to cure for probably like an hour or something. Then we'll stick everything on.
6.5 hours later.
Good. Anyways, this is the tank we're gonna be mounting the thing on. As you can see, I have 3 tanks. They're all connected. The middle one is the one that gets the water. So basically, the water will get just below the input take. So basically, when I measure that, it's this mark right here, right? So measuring from this mark to the top of the tank, it's like 45 centimeters. And from that mark to the basically the outtake of the tank, which is the lowest point we will have water, it's 132 centimeters. So these are the numbers. So basically, when it's full, it will be measure 45 centimeters. When it's empty, it will measure basically 177 centimeters. It's holding very well, as you can see. Things are holding. The parts where we glued the sealant seems to be working very fine. So hopefully it's waterproof. Let's now start mounting the things. So the first thing, and I think the only thing we're gonna mount, is basically the Arduino device, the board itself. Make sure it's not fiddling around. Seems to be fine. We're gonna open this door, this little thing, and tug the probe cable from this side. Okay? Rubber, so that's nice because it hopefully will shrink around, not shrink, but you know, like seal around it, right? I'm trying to get this inside the camera view. Okay, so we're inside. As you can see, hopefully it will be a tight fit. If it's not, okay, so it's a little bit big, but it's there. I went ahead and applied the new measurements we had. So basically the full tank will be 45 centimeters the distance, and when it's empty it will be 177. Of course this might change once we actually have the thing, you know, running. Also I did one small thing, which is basically I also added a new key for a new measurement, which is the distance. This is to make it easier for us to kind of have the measurements, so when we want to modify the numbers we have them. So basically when the tank is empty we know the maximum distance we have and the minimum when it's full, so we can fine tune it afterwards. And what I did is also, and I'll send it also basically as a new signal. And it's done. We have the sensor, everything works fine. I'm really glad I don't have to go to the roof again. I can get the readings on my phone. I'm gonna show you some of them. So everything works great. So right now, let's see if you can. Basically, it says 70%, and if we look at the distance, as you can see, 84 centimeters. So everything works fine. So what are my thoughts on the whole thing? It's definitely something worth to try, but I would change two things. The first thing is that I don't think Wi-Fi is the best choice. Even though I have my Wi-Fi reaches the roof, but it's not very reliable. It keeps disconnecting, and I think a better solution will be using the GSM Shield. Using like 4G, 3G, whatever is available. And the other thing is that using a battery, the 9-volt battery, doesn't seem to be the best choice. The life of the battery ran off in 2 days. I had to change the battery, it's kind of, the 9 volts is a little bit expensive. So I think a better solution will either be using a solar panel to power it, or a power outlet, near to where you're gonna install it, and use basically an adapter with the USB cable. Would be better. But anyways, it was a very fun kind of experiment. Now it's working. If you like it, please leave a like on the video. Put in the comments any thoughts you have, any ideas you might want to kind of test out. And please, if you kind of do this project, send me pictures both on Instagram or Twitter. I would like to see what kind of things you do, guys. And if it happens that you're new to the channel, it would be great if you subscribe. So that's it for now. See you in the next video. Bye bye.